14.3 number 1, I am told to find the partial derivative with respect to x of this function of two variables and the partial derivative with respect to y of these two variables. So, to give context, I've said if f of xy is equal to this, that is a specification of the rule of correspondence for f, right? It's an algebraic specification of the rule of correspondence. And so the domain is conventionally the natural domain. You can figure out the range based on that. Okay. Then the partial derivative with respect to x. Right, so this combination of symbols simply stands for the partial derivative with respect to x of f. Okay, so that is a function. The symbols that I've written down right here are the partial derivative of f with respect to x. Okay, so this function, I need to say what this function is. In order to describe that function, I will simply give its algebraic rule of correspondence. I will say that it assigns to the ordered pair xy, and then I'll think for a second. The partial derivative with respect to x is meant to treat x as a variable and y as a constant. And so I think of minus 3y minus 4 as simply a constant, and a derivative of a constant would be 0. So those parts are 0. The derivative of x squared with respect to x is 2x, so this will be 2 times 2x, or 4x. Alright, so the derivative with respect to x of f evaluated at xy is 4x, independent of y. And I am also supposed to find the derivative with respect to y. Those words are symbolized here. Right, this is shorthand for the derivative with respect to, oh man, typo, the derivative with respect to y. There it is. Okay, the derivative with respect to y of, now you'll often see me and a lot of other people write things this way, with the f to the right of the d dy. So I tend to think of this as a thing, in particular as a function that turns functions into functions. Okay, so that is to say the derivative, I think of that as, the jargon as an operator. This operator will take in that thing and give out yet another thing, much like what happened up here, right? The d dx took in f and gave out a different function than f. This right here is a different rule of correspondence than that, and so this function is different than that function. Of course, the derivative function is a different function than the function itself. So, now I'm going to think of, let's see, just for the sake of highlighting what I'm thinking. That right there is the name of a function. And when I evaluate that function at x, y, the ordered pair of numbers, I'll tell you what I get. Okay. Now, this time I meant to think of x as constant and y as variable. So the derivative with respect to y of 2x squared is 0. And the derivative with respect to y of negative 3y, that's simply negative 3. And the derivative with respect to y of 4, well, 4 is a constant, so 3. Okay. So the two partial derivatives, the partial derivative with respect to x and the partial derivative with respect to y, are indeed different functions. As for why I like this notation so much, you'll find as you go along that as you think of things more and more abstractly, you'll be thinking of the derivative, not the derivative of f, but the derivative, this operator right here, more and more. Okay. It's actually not far away, maybe 10 minutes worth of video making. Okay, see you soon.